Now it's time to test our Cryptos token. So before deployment on Rinkeby test network, let's test the contract using the JavaScript virtual machine. So the in-memory blockchain. Using the first account, I deploy the contract. Okay, there is one problem. When I try to deploy the contract, I got this message. This contract does not implement all functions and thus cannot be created. Why is that? Of course, because our contract doesn't implement all functions of this abstract contract. And this is mandatory. A contract must implement all functions of an abstract contract or of an interface. So I can't deploy the Cryptos contract without implementing all functions. We'll implement all functions. This is for sure. But now, at this moment, we just want a basic token. So I'll comment the function that I didn't implement. So these three functions and this event. Now everything is okay. In a following lecture, we'll continue our example and we'll implement also these three functions and this event. So now I can deploy my contract. The Cryptos contract has been deployed and let's see what is the balance of this address. I copy the address and paste it here. Okay, the owner has the total amount of Cryptos, 1 million. Okay, if I choose another account, let's say this account, and I paste the value of that address here, that address has 0 Cryptos. Because at the beginning, after deployment, the founder, which is msg.sender, so the account that deployed the contract, has all tokens. Okay, let's try the transfer function. So the account that owns all tokens, the first account, wants to transfer to this address. This is another address from here. The third address wants to transfer, let's say, 100 Cryptos. This address should be written between double quotes and transfer. The transfer succeeded. If I want to see the balance of that address, we can see the balance is 100. So the account has 100 Cryptos. And my owner, this is the owner or the founder, has this value. So 1 million minus 100. I can also get the balance of an account by calling balances, because this is a public variable and the getter function is automatically created. But the interface requests a function named balance of. So this is why I created this function. Okay, the name of the token, the total supply, the number of decimals, and so on. Now I think it's time to deploy our new token on a live Ethereum blockchain. Of course, we'll use the Rinkeby test network because we don't want to pay real money for deploying this token. It will be no difference if we deploy the contract on main Ethereum network. We need MetaMask with an account that has a balance of Ether because we must pay for the gas. And here I'll select injected Web3. It's very important that MetaMask should be unlocked before deploying the contract. Otherwise, we'll get an error. So I have already done that. I unlocked the MetaMask, but be careful. If you get an error, you should verify that MetaMask has been unlocked. So I'll press on deploy. The MetaMask window appears. Now I can choose which account deploys the contract. Let's say the third account. The third account deploys a new contract. I can edit the gas fee if I want, but there is no need for that. So confirm. the transaction has been sent to the Ethereum pool of transactions and waits there to be mined. Let's click on this link, and here on Etherscan we see what happens with our transaction. So our transaction is a contract creation and the transaction has been confirmed. I refresh the web page and we see here we have one block confirmation. So our Cryptos token is live. This is the contract address. Very important, when someone wants to transfer a token, that account doesn't transfer or send tokens to the contract address. If you try to send a token to the contract address, you can lose the token. The tokens are sent to an externally owned account address, so to an user address. Behind the scene, the account that sends tokens calls the transfer function of the token contract. So let's try to transfer our Cryptos tokens. First, in MetaMask, having a custom token, we must add that token. So here we have a button, add token. I copy the address to clipboard and paste it here. Okay? It automatically takes the token symbol, number of decimals, 0. Next. And we can see our token. So that account, the third account, has 1 million Cryptos. And finally, add tokens. Let's send some tokens to another address. Okay, I have another account that has this address. So I copy the address and here using MetaMask, I'll send, let's say, 100 Cryptos to that address. Here I selected Cryptos, send, the recipient address, this is also my address, and I'll send 100 Cryptos. Next, and confirm. The transaction has been submitted and the transaction has been mined. If you want the transaction to be mined faster, you should increase the gas price, and that can be done in MetaMask window. Now let's check the account of the recipient. So I'll use my Ether wallet and I'll open the JSON file that contains the encrypted private key associated with this address. This is also my wallet. So here on Ether wallet, view wallet info. I'll select here JSON file, select, and the JSON file. Now the password and unlock. Okay. This is the balance of this account. There are 0.5 Rinkeby Ether, but no Cryptos. There is no Cryptos because we should add a custom token. So my Ether wallet doesn't know about my Cryptos token. So here, add custom token. I'll copy paste the contract address. Here, token symbol, CRPT. And decimals 0 and save. And the Cryptos tokens have been loaded. So we have 100 Cryptos in this account. Okay, this account can send his Cryptos to any Ethereum address. For example, let's try to send some Cryptos to another account from MetaMask. So I open MetaMask and here I'll select the second account. Copy to clipboard and back on my Ether wallet, send Ether and tokens. I must select the JSON file one more time. Paste the address. I want to send CRPT and I want to send, let's say, 15 CRPT. As you can see, my Ether wallet automatically increased the gas limit because this is a special transaction using a smart contract and consumes more gas. And now generate transaction. If I want, I can increase the gas price here. If not, 10 gigaway is okay. And send transaction. Here I must confirm the transaction. And I'll verify the transaction on etherscan.io. And the transaction has been mined. Now I want to show you something very important. This is extremely important. Millions of US dollars have been lost because users sent tokens to contract address instead of externally owned account addresses. This externally owned account sent 15 cryptos to this externally owned account. Okay, let's take a look here. Here it seems a little bit strange because the transaction seems that was generated by this account, the address that starts with 567, but has been sent to the contract address, the address that starts with A5. This is the contract address. And I've just said don't send to contract address. This is strange because I didn't send to the contract address. In fact, I sent to this address, to the address that starts with 465. Okay, the address from here. What's happening here? The application, the wallet, this is my Ether wallet or MetaMask, behind the scene sends the transaction to the contract address and calls the transfer function. So in fact, the transaction has been sent to the contract address and the transfer function has been called. The wallet does this automatically because it knows this standard, the ERC20 standard. So even if the user sends and must send to an externally owned account, the transaction is sent behind the scene to the contract address and the transfer function is called. And the transfer function has two arguments. The transfer function has an argument of type address 2 and another argument of type uint tokens. So here is the recipient address, is the address written in my Ether wallet or in MetaMask. Let's come to a conclusion. We always send tokens to an externally owned account and not to the contract address. But behind the scene, the wallet calls a function of that contract using the contract address and passes the recipient address as parameter to this function, to the transfer function. Okay, that's all. In the next lecture, we'll implement the other three functions of an ERC20 token. So these three functions. In the end, we'll have a fully compliant ERC20 token. See you soon.